Hey guys, welcome to another Angular online session. So as you can see, I decided to go back outside. You have Diamond Head right here. You can see right here. Beautiful weather in Hawaii. Just, chilling on the beach, bringing you some sunshine. So it's exciting. You're there at home. You're back again, seeing all of us here. We have some exciting news and amazing presenters. We have Valentin that seems to be ready, and Minko that's just getting ready for you guys. So once again, aloha and welcome to another event. Enjoy.
Okay, Ski, thank you so much. Can you hear me? Yeah, perfect. Thank you so much. So it was, as always, great introduction, great music introduction. Okay, so now we start officially. We have two guests today, as you said. And first in the line is Minko. Hey, Minko, can you hear us? Hello, Minko, can you hear us? Okay. Can you hear us?
Yeah, I hear you.
Okay, perfect.
I'm working on connecting my headphones now.
Yeah, okay. Yeah, so now we can start.
Sorry.
Yeah.
I'm still working on connecting my headphones.
Yeah, no problem. Ski, can you repeat the song, maybe?
Just the background noise, sending
Sorry,
positive aloha.
My headphone doesn't quite work yet.
The power of music works. I wonder for you guys online, how many of you actually play any instruments or, picked up a uke? It's an awesome thing to do in your spare time, and really easy to learn. 4 strings, come on. So yeah, I don't know. How about Minko? Did the music help and you're connected? I think Minko is, the music hopefully gets through. And it's really, I'm looking at his reaction. Minko, can you hear me? Minko.
We can start with Valentin first. I still have some technical issues.
I think we can start. Valentin, what do you think about that?
The floor is you.
Yeah, sure, why not?
Yeah, let's do
Always
it.
ready.
Aloha, bro.
That's not a problem. So, okay, we're going. I actually hear the YouTube streaming in another room, so that's nice. Okay, let me share my screen where I can do this in Zoom. Yeah, here. Darius, Zoom told me that host disabled attendee screen sharing. Yeah. And give me a second, please. Cool. Everything's fine? We can start. So, hi everyone, once again. So we had a kind of interesting start with a lot of songs and nice things. So thanks a lot. First of all, a little bit about myself. My name is Valentin Kononov, and I'm mostly working with the Typescript. And I had experience with Angular, with React, with a lot of different stuff. And another thing I do, I try to attend some conferences and speak about interesting things. And today we are going to speak about decorators in TypeScript. Actually, just because this is so interesting thing that it was a kind of a basement for Angular, and so it's heavily used TypeScript and decorators and metadata and stuff like that. And another one thing, which is Nest.js, which is heavily inspired by Angular, and I love this framework so much that I did several APIs for the work with it. So we'll touch bases a little bit also. So I'm writing a blog at kononov.space website, so you can check out some of my articles there. And I will share all the links to this presentation as well. And just a couple of words, I'm working at the moment at Mapbox company. We do a lot of mapping and navigation, interesting stuff. So let me know if you want just to know information. Link to the slide deck is here, and there is a link to an article where I have most of I will be talking about right now today. So let's start. Decorator. What is it actually? So when I was thinking about it for the first time, I was thinking like something like that. And this is actually a real photo taken by myself when I was in Thailand for the first time. But getting back to business, to some development, in general, we are thinking about decorators like having add symbol and some word. And what is that, in fact? So what we have under the hood? According to the documentation, decorator is a special kind of declaration so that we can add some additional behavior to function, to some accessor, to some parameter of a function, to a field, or maybe to a whole class. And we can read a lot of documentation about that. And we can also remember the book of Gang 4 and their definition of that. Like decorator is something which adds additional behavior. So in TypeScript, it's a function. It's just a function. Most of the things we have in TypeScript is just a function. So decorator is also the same. So let's take a look to a couple of samples just to get into a little bit more context. So here we see the ng module decorator in Angular. So with that, we can specify a lot of needed metadata, like which module we import, what we export, so on and so forth. Another sample for the component. So we define some settings exactly for the component. And these settings will be used by Angular compiler when the code will be handled and will be compiled to the JavaScript. With the help of this metadata, Angular renderer will know what to do. So maybe the sample is a little bit outdated, so I did it when the latest version was Angular 8, but it serves the matter. And another sample is from one of my Nest.js projects, and it has decorators from class validator library. The primary purpose of it is just to define some validation rules, or to define, for example, if you use type-ORM, you can define how this field will be mapped to database. So a lot of different cases from different libraries, which we all know about. But it's worth to mention that I don't know, TypeScript is here on the stage since 2012, but decorators and metadata is still a part of experimental features. So you should make sure that you turned it on, so in your tsconfig file. So, okay, that's cool. We already have decorators, so we're done. But we can create something special and something practical for ourselves by decorators. So let's think about some practical cases which might not be covered heavily by other libraries. So, for example, we can create some custom decorator for a personal login. So if you want to have some special login behavior, so you can do it. Another area is validation. So we already have the class validator library with a lot of stuff, but you might want to have something special, something for just for your business logic. And in general, it helps to transform how you write the web applications to some kind of meta programming style, to declarative programming style. And all that makes your code a little bit more readable. So you don't need to see like, okay, this function calls this function and the result is passed to this function. You see just a small little decorator with some parameters and you can read it and it's just nice. Okay, let's do this. This is one more question actually. And one more interesting thing. In current version of TypeScript, you can do couple of, you can try to add decorator to a function inside the class, or you can just write a function. But in this case, this will not work. So decorator cannot be applied to just a function without outside of the class in the current version of TypeScript. Yeah, just this variant is possible. It is so because of nature of current version of TypeScript, because it heavily uses reflect metadata and all this related stuff, and it needs something like a prototype or something to store this metadata, as far as I know. So if you just write a function without class, you don't have this. So it's a current limitation, just natural one. Okay, let's just try to read some code. So my idea is that we try to write the log time decorator, which we will be able to apply to any function inside any class, and it will put to console log the time spent for this particular function. So it looks like that. What's interesting inside? First of all, decorator is a function. And it's function which returns another function with some specific arguments. And these arguments are target, some property name, and descriptor. In fact, the property name is just the name of a function. And target is the instance of a class where this function was called. These arguments will be filled by executing environment. So when we compile it to JavaScript, we will see actual call of this log time function and these parameters specified. We'll take a look on one of the other slides, actually. Descriptor is another interesting thing here because the value property of a descriptor is our initial function, and we can save it and for the future use, and we can then replace descriptor value with our function. And by that, we can decorate and we can modify the initial behavior of the function. And it will behave a little bit different. So for example, in this case, we use console time and console time end to track the time. And using the method apply, we can actually call our initial function and return result, of course. If we don't return result, we'll just lose it, actually. So this is the sample of function decorator. Once again, function decorator receives target. It's an instance of an object where it was called. It received the name of a function in case you need it. Maybe you would like to put it out somewhere. And the descriptor, which has several things, but the main is the reference to a function, which is decorated. If we compile it to JavaScript, so interesting things starting to go on. I actually really like to type something in TypeScript and see what happens in JavaScript, actually. And it's sometimes it's nearly the same. Sometimes it's just going crazy. And if we compile the code of decorator itself, it pretty the same. So the only thing, we lost all the types, right? So we don't have the property, the string as a type of property name and so on. But in general, we have nearly the same structure. Function, which returns another function, descriptor, the same. Yeah. But if we take a look to the JavaScript code, which uses this function, which we decorated before, it looks drastically different. So when we define the class with that function, the class itself nearly the same. But after that, we see the decorate with a double underscore function, which is a system function. I mean, not system, but it's some function created maybe by TypeScript compiler, which actually calls our decorator and puts there all the needed parameters. Like, what is that? It's function. No, here, the target, and it is exactly prototype, the name of a function which we are calling, and something else. It's nice, and it's good to know because when you are writing a decorator and when you're applying it to some function, you should know that it will be call of this function somewhere. And for a case of a function, it will be called each time when the function is called, basically, because of this decorate with 2 underscore call. Okay, moving on. If we have several decorators, that's fine. You can use it one by one. And in JavaScript, they will look nearly the same. JavaScript also will put them in the same order, one by one, inside the double underscore decorate function. Everything else is the same. And let's move on. We've been talking about the function decorator, so how we can add additional behavior to function. Another area for the decorators in TypeScript is a class decorator. And for this topic, I would like to suggest to implement the little tiny personal dependency injector. So just think like we're starting Angular 10 years ago. We want our dependency injector. So let's try to write it. First of all, I would like to think how it should look like from a developer's perspective. So I want to have some kind of service with constructor, with some other functions maybe. And I simply want to add some decorator and want to specify, is it class should be singleton or it should be able to have multiple instances. That's it. So I put there some additional text, but the main thing I'm looking for right now is this one. So just to modify, can we create the several instances of this class or cannot? Let's move on. What we need for this? So we need to implement the decorator itself. And in fact, if we take a look to some Angular decorators or to some Nest.js decorators, in most cases, they will do one thing. They will just put some metadata somewhere, and that's it. So decorator for class, in most cases, is not actual behavioral modification. Is saving information for this class, how it should behave. And this information will be used by some other consumer. It can be compiler, it can be other code, doesn't matter. So for this case, I want to save some metadata. So I like TypeScript, so I created an interface with all needed properties. And I created the custom behavior decorator itself, which receives the metadata, which I'm putting in. And what should return the class decorator? The same, it should return a function, but the parameters of this function will be different. In fact, the decorator for class should receive just one parameter, which is constructor of this class. That's it. And what we do? For this case, we just need to put the metadata somewhere, and we use reflect.define metadata. It's a TypeScript library used a lot in different places for this purpose, to put some metadata for the class or for just anything actually. And basically TypeScript itself uses this library. So for example, during the compilation of a function, TypeScript puts to metadata, to reflect metadata, information about the function parameters from a design time. And basically, you can read it and do something with it if you want. Moving on. So just once again, this is a reference to class constructor, which decorator will receive. Let's compile it. After compilation, we see a slightly different picture from what we've seen before, because here is our basically class definition in a JavaScript. And again, we see the _decorate function, and we put there our custom behavior function. We put there some additional metadata, and that's it. The interesting thing is that this all will be called only once right after JavaScript engine will read your code. And this will be executed only once. So function decorator will be executed multiple times every time you call the function, but code of class decorator will be executed only once during the first reading of a file with your with code of your class. That actually good to know. I think we skip it. I already talked a lot about it. How we use it? How we use our dependency injector? So basically, what we might think about, we need to have the kind of map where we will store instances, and we need to create the function getInstance, which will and we pass the type. So the type of instance of which we want to create, and this function will get the metadata which we already stored as a decorator, and by this metadata, it will understand. Okay, so if this class is a singleton, okay, we need to check. Maybe we have already instantiated it, and if yes, we can just return it, and if not, we can create a new type. But if it's not singleton, we just return the new instance of this type, and that's it. So at the bottom, you can see the code, how it can be used. So for example, when we want to have instance of our test service deco class, we just call getInstance and pass there the name of a class. So that's basically it. The idea and main purpose of this slide and this sample actually to bring you information that in most cases, we don't have the behavior modification inside the decorator itself. In most cases, decorator serves the purpose to store some data about how this behavior should be modified. And this data, this metadata, will be used by someone else. For example, like this getInstance function. Moving on. Okay, property decorator. So we've been talking about the function decorator, about the class decorator. There are also decorators for properties. And the primary area of usage for this is a validation. It's very convenient to write some code of class and to put information about how this class should behave, how it should be validated right inside of it, like this, for example. This is a sample I just made up for this slide. For example, I have the class person in my database, and I want to validate that the person I store has age from 18 to 60. I don't know why. Maybe it's the rules of my local government. I don't know. But I just want the easy way to validate. So let's try to implement this kind of decorator. Again, we are writing function called age here in this sample, and we're putting two arguments here, what we actually expect and what we will put to the code by ourselves. And again, what we do inside. Oh yeah, interesting thing that we again have a new signature of the return function. So for property decorator, the return function should receive prototype of this class and the property name. So JavaScript will put this information for you, and you will know which property you are in right now and what is the prototype. So you can get, for example, name of this class if you want. And again, by this code, we just put some metadata. So we have the from and to, and we define metadata for them. For prototype constructor, it's actually doesn't matter what you put here, but it should be something stable. It should be some stable reference which will live through all the life of your application. And it's actually your metadata will be linked to it. So we saved the metadata for the age validation, and we can take a look to the JavaScript code, how it looks like. And again, we see the class definition in JavaScript, and then right after that, immediately after that, we see the code of decorate function with our parameters, with our 18 and 60 parameter, and with passing a person.prototype, with passing the as an object, with passing the age string age as a name of a property. This is important because once again, looking to this code, we understand that the code of decorator will be executed just once when the JavaScript engine will look to it for the first time. So it doesn't execute multiple times. That's why the only thing we can do, we can put some information about our case somewhere, like the metadata. And usage of it will be something different. So usually some libraries like class validator will implement the function, simple function called validate, which will receive the object, and that's it. The idea is that we do not pass too much information into simple validate function. We pass just one object, and that's it. All the validation information it needs, it will actually can get by itself just from metadata. And so this code is about it. What we can do, we can list all the properties of an object using this one. For each property, we can get our metadata, which we define. And we can actually generate the key. For example, if we have several properties, we can put metadata for each property separately. And so by having combination of strings, we can define different metadata for different properties. And basically, that's it. We're just checking that we have metadata for this property. And if we have it, we can do actual comparison. We compare our value from object. We already have the instance of an object. Having the property name, we can just get access to it, and we can compare. And that's it. If validation is passed, that's okay. We don't need to do anything. If it's incorrect, if something's wrong, we can throw a new error or do whatever we want for the case of our application. So, for example, like in the bottom, this sample will pass, will be fine. But if we put something else, like 61, we will see the validation error. So this is a very simple code. It's just targeted to demonstrate the basic idea about all this case. If you want some more comprehensive solution, you can check out the existing class validator library. It's very interesting. It has just a lot of stuff for code validation inside, like is it male, is it integer length, and so on and so forth. And how it works is the same. You define the several validation decorators for the entity itself, and then you just call the simple function validate with object. It returns you a promise. On a then handler, you are okay. On catch handler, you have errors, Or maybe I'm wrong, but you can also catch errors and receive the list of validation errors and show the user something or whatever. And yeah, I was thinking so much about it. I was thinking so much about the TypeScript and validation, so that I created a small library and put it to NPM. And the idea of that, just for testing, was like, okay, I want something super simple, super easy, like one decorator without any parameters, which I will put a function, and it will check that the actual arguments which were passed to this function equal to what I expect in a TypeScript. So I created that decorator. I used the metadata a lot, and there is a simple version, so you can just download it and try. But I found some limitations of the current version of TypeScript. For example, we don't have metadata for array items. Or again, we cannot define the decorator for a function outside of it. So that was interesting try, but it's not perfect, unfortunately. What else? I think we came to the very end of my presentation, but we didn't talk about the fourth type of decorators. It's decorators for the function parameter. I think it will be a good homework. So if you will spend, for example, 10-15 minutes reading documentation today or maybe tomorrow morning, and we'll implement something very simple decorator for the function parameter, which will, for example, check that the actual argument simply is not null or undefined. I guess so. It can call it required. I guess it's a nice touch. You can try and just get a feeling and hands-on experience how it works. So just to sum up, we're talking about decorators and that they help to bring some custom behavior either directly if it's a function decorator or by putting some additional information to metadata. And all that will help you to practice the kind of declarative programming or meta programming and make your code much more readable, at least from my standpoint. And having all that helps you to enjoy your code much more and write the better code rather than just spending time for some debugging and some issues. I think I'm done. Thanks a lot, guys, for your attention. Thanks, Darius, for invitation. It's a great pleasure and
Thank you so
to be
much.
here, and I'm really proud of it. Thanks.
Thank you so much, Valentin, for this valuable informations. Great presentation. Thank you so much. So next in line is our guest from US this time, and it is Minko. Minko, can you unmute? Okay.
Yeah.
Okay,
Yeah.
perfect.
Do you hear me well?
Hello.
Hey, do you hear me well?
Yeah. Everything
Okay.
is...
And you see my screen?
Yeah.
Perfect. Let me just minimize the Zoom two parts. Okay. Yeah. So hello everyone. My name is Minko Gechev. I'm working at the Angular team at Google. Today, I would want to share with you the current state of the Angular's deployment, server-side rendering, and pre-rendering. If you have any questions, feel free to ask them in the YouTube chat, and I'll be happy to answer right after the presentation. So in this presentation, we're going to go through the very old days when the web was still a brand new thing. We're going to talk about different rendering strategies: client-side rendering, server-side rendering, and pre-rendering. And we're going to trace this evolution of server-side rendering over time until we eventually reach out the current state that Angular is in right now. So back in 1991, the web was a much simpler place. It was still a fascinating distributed architecture where we had different web servers delivering static HTML pages to the browser. It was fault tolerant because, well, it was distributed. We were able to navigate across all these different web servers just by following hyperlinks. on the web pages. And this was serving the purpose and filling the needs of the users pretty successfully for quite some time. But right after that, folks noticed that it was really hard and even impossible to generate the web page on the backend dynamically, depending on who is requesting it, for example, or accept user input. That is why a bunch of different developers came up with the idea for the common gateway interface. And this is just an interface in the web server which accepts the user requests and forwards it to an external program, which can handle the request and return a response. This external program accepts the request and it can do anything, pretty much. It can fetch data from a database or from the file system, and even it can save some data coming from the user in the body of the request or coming through parameters of, let's say head or a GET request. So CGI was working great. And as you can see here on the slide, once the user requests the page, we're running a bunch of scripts on the back end. They're fetching some content from a database, let's say, and right after they're rendering the page. So at this point in time, the user already sees some useful content. This is the LCP marker here. LCP stands for the largest contentful paint, which is a user-centric metric that is coming from the Chrome team, which estimates when the page is useful for the user. Notice that I'm saying just useful. It doesn't mean that it is interactive in the same sense that JavaScript pages become interactive once you load a bunch of scripts. The user just can engage with the content, they can learn something from the page, and they see something. So they're already able to get some value out of the page right after the response. The drawback of this approach was, though, that each page request, each page action was requiring an entire page reload. Imagine you have a poll on the page and you just want to submit your vote. Well, this would require the browser sending a post request to the server, the CGI script handling this post request, and right after that, regenerating the page again, and, well, the browser re-rendering this dynamic content that is coming from the server. So this is not very convenient, especially for such tiny interactions or incremental page loads. That is why with the evolution of web standards, like coming with iframe, XML HTTP request, and even ActiveX in Internet Explorer, different folks were able to come up with the idea for AJAX. AJAX is just a combination of different technologies that provide some like incrementality and improvement of the developer experience for the web. With AJAX, things are slightly different now. First, the user is still sending a request to the web server, which is forwarding this request to, let's say, a CGI program. Or which in the era of AJAX, this was more likely a request coming to an Apache server that was forwarding the request execution to a PHP script. And right after that, the user was directly getting the largest contentful paint. And the page is completely useful for the user at this point. Later on, the page was often referencing a bunch of scripts, a bunch of JavaScript that was just attaching event listeners to the DOM and making the web app more interactive, so that when the user engages with the poll that we discussed in a bit, like a few minutes ago, instead of reloading the entire page, the JavaScript associated with this poll is just able to send an AJAX request in the background, perform the vote, and right after that, we were able to recompute the results in the browser and display them without reloading the page. So this here is the time to interactive. First, the page is being useful for the user when we get the largest contentful paint, and right after that, we're making it interactive once we load all the associated JavaScript with it. Well, this was around the time when I first got introduced to web development. This must have been around 2006, and that's the authentic cover of the first book that I read. In Bulgarian, this stands for Development of Projects for Web with PHP and MySQL. this is the first website that I developed, one of the first websites. In fact, it was an entire CMS system, and one of the websites that I built with it was this mountains.skobg.org, which was pretty much the website for the local mountain chain that we have in Bulgaria. And I even presented it in front of a jury, in front of these two people. It was a very exciting moment for me because for the first time I was presenting my work in front of other people who were actually very competent, and they were able to give me an excellent feedback. This is thanks to my high school teacher as well, who pointed me to the right direction and helped me to grow this set of skills. So at this moment, there was another rise of the front-end frameworks. Originally, Backbone first showed up, and right after that, AngularJS, and they were attempting to make the web applications have even more fluent desktop-like user experience and put some structure onto the spaghetti code that we used to ship in the browser. With both Angular and Backbone, the way we started building web applications changed a bit. Now, instead of using server-side rendering with something like CGI or PHP and Apache, we started just shipping a plain index.html file to the browser. With this HTML file, we're referencing a bunch of other JavaScript files that were attempting to make the page interactive. So first, we would have to download the HTML file from our web server or a CDN. Right after that, the browser needs to start a sequence of requests in order to download all the associated JavaScript with the page. And finally, once we get this JavaScript, we execute it, we're able to render the page and make it interactive. This may sound good because at the same point, we're making the page interactive and we're also getting the largest contentful paint. But on the other side, the user sees nothing than a blank screen or a loading bar for quite some time. And the only thing as developers that we can do in order to shrink this time, to reduce it, to make the web page load faster, is just, well, to reduce the number of bytes of JavaScript that we're sending to the user. And this is not an obvious thing how to do at certain points. We as framework developers on the Angular team, we're constantly aiming to reduce the size of Angular applications. For example, we even had this joke on the Angular team that by version 5.4, we'll be able to make Angular bundle size negative. So you will be kind of earning bandwidth when you're building applications with Angular. Of course, this is unrealistic, and we still have a long way to go until we achieve the optimal bundle size for Angular applications. But at certain point, well, you should just ship some JavaScript, right? We're shipping some functionality to the user, and this functionality we're implementing with JavaScript. So there is no way for us to just ship zero kilobytes of JavaScript to the browser. That is why, in order to speed up rendering with front-end frameworks, different folks started thinking that maybe they can perform this kind of client-side rendering on the server in a similar way that we do in CGI, but this time by reusing the entire logic of our application, of our client-side application. This was also the rise of Node.js. So this must have happened around 2010, I'll say, or 2012. With server-side rendering, the browser is still sending a request to the web server. The web server this time, it is able to forward this request to, we have this actually an application server. So the browser is sending a request to the application server, and in Node.js environment, we are running our client-side application. Often, instead of providing a headless browser, we're just providing a tiny shim which emulates the DOM, but it's not the real DOM. It just tries to satisfy the requirements of the framework so that we can run our client-side application on the server. And right after that, we're providing this rendered content to the browser together with a bunch of scripts, and we're rehydrating the application. That's the process of rehydration here. We have the rendered content, and now the framework takes over in the browser. It attaches different event listeners and makes the page interactive. This was around the time when I gave my very first international talk in Vegas in 2014. I talked about how we can use immutable data structures with Angular JS back then, and how we can be productive with it. I was super nervous to be there. In fact, after my talk, I went directly to my room and I locked myself there until the very late afternoon. But on this conference, I met Patrick. And Patrick and Gechev, about 2 months after NG Vegas, they came up with the first version of Angular Universal, which is the first server-side rendering solution for Angular. Together with community since then, we kept working on Universal in order to make it a very robust industrial solution that is currently used by a large amount of projects, like hundreds of projects worldwide. Some very high traffic websites, such as Crunchbase, are constantly using Angular Universal in order to speed up the initial load time for their users. But over time, two of the biggest challenges that we hear about Angular Universal for developers using it are the change refresh time and the deployment. The change refresh time refers to the time between saving a file on the disk and right after that previewing these changes in the browser. So that's why we developed an Angular Serve SSR builder. This is something quite similar to ng Serve, but for Angular Universal projects. So we're watching both the client and the server. And when we notice that there is a change in any of them, we're rebuilding both the client and the server and refreshing your browser after that. Notice that this is not a complete replacement of ng Serve because we're doing more work and we cannot be as fast as ng Serve. But it is still a decent way to improve your development experience when you're developing pieces of your application that impact both the client and the server. In order to take advantage of this feature, all you need to do is just use ng update and just update your ng Universal Express or Happy Engine, depending on what you're using. This feature was developed in collaboration between our community and the Angular team. So Alan from the Angular CLI team worked very closely with Manfred, who is one of our very committed collaborators, in order to make Serve SSR available for everyone. The second thing is deployment. So there are very well documented tutorials or like guides on how to deploy an Angular Universal application to different on-demand computing engines, such as Cloud Functions or Firebase Functions, Cloud Run, and so on and so forth. These are really like great guides, but at the same time, they were requiring quite a few manual steps. And well, we wanted to automate the process. That is why we combined forces here. We collaborated very closely with the Firebase team in order to deliver ng deploy for Angular Universal applications. You should first run ng at Angular Fire, and right after that, we're going to install a bunch of dependencies and check your project. In this case, since I run ng at in an Angular Universal project, Angular Fire is going to ask me whether I wanted to deploy it as a Firebase function. So I can just agree. When I press yes, we're going to install a couple of other dependencies and fetch the project list from your Firebase account. When you select a project, you can just type ng deploy, and that's it. We're going to build both your client and your server with the most like optimal production settings. And from this point, all you need to do is just wait a couple of seconds until we deploy your static assets to Firebase hosting and your server-side logic to a Firebase function. Now, when you click on the URL, you should be able to see a server-side rendered Angular application. We can verify that by looking at the source code. So this way, with just 2 steps, you can go from development to production pretty much. You just need to run ng at Angular Fire and right after that, ng deploy. So when you deploy your Angular application or like any server-side rendered application really to a server in general, there is one very common problem. Now imagine we have user A, and user A is sending requests for a specific page. This means that the server needs to server-side render this page, and right after that, return the static HTML to the client. If user B opens the exact same page, we're going to repeat this behavior. We're going to render the page on the server and return it to the client. And this can repeat quite a few times. Imagine you have a very high traffic website with hundreds of thousands of users. You're going to re-render the same page all over again, doing the exact same thing. You're going to lose a lot of resources, computational resources, So, well, your bill at the end of the month is going to be pretty high. What a lot of people do is introduce a caching layer. So when you send a request, first it goes to the cache. We check in the cache whether there is a response associated with this request. If there is one, you can directly return it. Alternatively, we're forwarding the request to the Firebase function. Let's say it is rendering the response, we're putting it into the cache, and right after that, delivering it to the user. This is another solution. The problem here is that we're introducing one more component in our diagram here. So we're making things a little bit more complicated. And at the same time, we also need to think about what keys are we going to use from the request in order to implement this caching, and also how are we going to implement this caching in validation, which is often a big problem when we're using any caching strategy for anything pretty much, from memoization to server-side rendering caching. That is why in such cases, I very frequently recommend to use pre-rendering, if possible. And not only for applications that are requiring server-side rendering, but for most of them. Even if you pre-render just a tiny bit of your website in the form of an app shell, pre-rendering is still an excellent option. So pre-rendering is something similar to server-side rendering, but this time instead of rendering your application on the server, you're running it as part of your build process. That is the only difference. In order to use the pre-rendering that we introduced in Angular Universal, all you need to do is just run ng-add, first ng Universal Express Engine, and right after just run ng-run, the name of your project pre-render. And that's it. From here, we're going to first build your application, and right after that, discover all your routes without parameters in your app and pre-render them and generate static HTML files for them. So yeah, notice this is the exact same thing as Angular Universal, but this time we're running it as part of the build process. And this time, we don't really need to have any complicated server-side logic that is performing server-side rendering, because we're generating static HTML pages that we can deliver from any CDN. We also played with this in order to make it optimal. So for 800 pages, we need about 2 seconds to pre-render them, and some folks push this even further. So Steve here rendered 10,000 pages for 75 seconds. I would say that for rendering, he used about 15 to 20 seconds, and the rest we spent in build time. But that was a pretty decent result. With pre-rendering, we're an even, like having native support for pre-rendering, we're an even better citizen of the Jamstack. The Jamstack is this new paradigm for building web applications. You remember previously we had the LAMP stack with Linux, Apache, MySQL, and PHP. Now we have the Jamstack, which is, I'll say, even more simplified, because we have JavaScript, APIs, and markup. We need to know only JavaScript. We need to know how to interact with different APIs, let's say Stripe and Shopify. And we also have markup. This is the static HTML that we're generating out of our client-side rendered app. We can do that with Angular Universal. There is also a community-driven solution called Scully. This is the static site generator for Angular that is developed by Hero Devs. They're using a slightly different pre-rendering approach. Instead of using Universal, they're using a headless browser, which makes things a little bit slower in terms of rendering, but at the same time, you can use all different APIs that you want to in the browser, and Scully is still going to use, because remember, we're not running the application in Node.js environment. And in Node.js environment, we need different shims in order to cover all different DOM APIs that are not available in Node.js. With Scully, all you need to do is just run the headless browser that Scully is going to do automatically for you and output a bunch of static HTML files. So both have their trade-offs, and I would recommend you to pick the one that works the best for you. I don't know if you noticed how many times I mentioned collaboration and working together in this presentation. I'm really excited to be able to work in this environment where we're driving the technology forward just by working together. I was on all different sides of this. I was working entirely remotely in the Angular team, just as a third-party contributor, just contributing in my spare time. Later on, I joined a little bit as a contractor, and I worked from a slightly different perspective. Later on, I kept contributing in my spare time, and now I'm contributing as a full-time member. So I really enjoy this active collaboration in the open source. Not necessarily Angular. In general, open source is a great way to share very distilled amount of knowledge and work with fantastic folks everywhere. So yeah, that was everything I had for you. I would love to answer your questions if you have any. And also, if you have some feedback about my talk, please just open mgv.io/talk. I would really love to hear your thoughts. Thank you.
Okay, thank you so much, Minko. Thank you for this great presentation with a lot of great stuff, especially the photos. I really like it. Okay, if anybody have any question, just you can use the YouTube chat. We have, I think, one question so far. 1 second. How about serving on my Linux server? This is
you can
from Aishan.
Yeah, you can use on-prem solution as well. I'm usually recommending something like on compute engines, on-demand compute engine as like Azure functions or like Firebase functions or Cloud Run, because you have to think about fewer things. You can definitely serve Angular Universal applications from your Angular Universal, your Linux server as well.
Okay, the next question is, Angular also has pre-render, then why we need Schoolie?
Yeah, that's a good point. So there are the two main differences are that Schoolie provides also a plugin infrastructure, so you can fetch content from different sources. They have kind of adapters for different content providers. You can plug your Angular application to a WordPress source, for instance. And the second is how we're doing pre-rendering. Schoolie is using Puppeteer right now, and their pre-rendering is kind of more complete. If we use kind of terminology from programming languages, it is more complete because everything that can run in the browser, they can pre-render. Angular Universal is slightly more restrictive. And because of these restrictions, respectively, Angular Universal performs faster. But yeah, you can pick between these two. We're working closely with Schoolie so that we can optimize their pre-rendering as well. Maybe eventually at some point, you'll be able to choose between different pre-rendering strategies.
Okay. Can we just use pre-render build to achieve the same? Yeah, but we talk about it. So any other questions?
Yeah, for social media crawlers, if you can use pre-rendering, use pre-rendering. I would recommend you to use pre-rendering all the time if you can. If you cannot, if you have very dynamic content on your page, that's the case when you should use server-side rendering. But pre-rendering, that's my favorite, because you just generate a bunch of static HTML files on your machine as part of your build process, and that's it. So from server-side rendering and pre-rendering, you get the exact same benefits in terms of SEO and social media crawlers. And it could be potentially even better if you use pre-rendering, because you're reducing the time, the largest contentful paint time, since you can deploy your pre-rendered assets directly to a CDN instead of delivering them from an application server. So that was the answer of when should I use pre-rendering or server-side rendering?
Should we always use SSR or?
Yeah, it depends if you're building an internal system, for example, where performance doesn't matter, where most folks are opening your web application through a local network, and they can afford to wait 1 or 2 seconds for the application to load. You don't really need server-side rendering. I'll recommend you to just use client-side rendering. yeah, when should I use SSR and when client side? Usually SSR is a good idea for most cases because, except when I mentioned that you're in a not performance critical system. If you're using a content web application where you generate a lot of content, like a documentation website or like a blog or like something in between these lines, or even an online store, then server-side rendering is very important because you need to make your web application really work really well with social media. It needs to be very crawlable from like search engines and so on and so forth. Also, when you're working on something performance critical where you would want to get the fastest possible, largest contentful paint, I'll definitely recommend you to use SSR. And can pre-rendered once use dynamic API to change the metadata of our app? Depends what you mean by metadata. If you're referring to the like metadata that you're attaching to the HTML, then it's not going to work. Well, you can update them, but probably to this point, the social media crawler will have already read the previous tags. So you cannot. For dynamic things, server-side rendering would be better. For pages which don't change that often, where you're not generating anything dynamically on the server, I would recommend you to use pre-rendering. Yeah, and there is a question, do you see any benefits from using SSR or pre-rendering for back office app where time is not relevant? No need. It's just going to bring extra complications. Can you combine PWA and SSR? Yeah, you can have server-side rendering and service worker. And there is one last question. When we use SSR, then we also need to execute JavaScript, but doing it on the server instead of the browser. So is it really big advantage of using it? It could be. Yeah, it could be. Again, if you are building something which is really performance critical and you have a lot of static content on your page that you would want to work great with social media and search engines, then you probably should consider using server-side rendering, or even better, pre-rendering if you can. Alternatively, it can be just a little bit on the expensive side if you don't need server-side rendering at all. There is no need paying for Firebase functions. Although Firebase functions, you can use them for free for quite some time. So if you don't have very high traffic, you can use them for free probably forever. But even maintaining a Linux server or just paying for the servers, excuse me, for the server of your application is not worth it. All right, yeah.
Okay, so big round of applause for Minko. It was a great presentation and a lot of great informations. One more time, big applause also for Valentin. Thank you so much, guys. It was a great to see you today. I will also invite you in 2 weeks. We have another session with Minko. It is a Q&A session, so you can prepare some questions and ask it. So see you in 2 weeks on the next Angular online event. So for today, thank you so much.
Thank you, Darius.
Thank you.
Bye everyone.
Bye everyone. Thank you so much.